Okay, now that you've seen the big idea of the chapter that we'd like to do inference procedures for comparing two samples, and you've seen how to determine in objective number 1 whether two samples were considered independent or dependent, and in objective number 2 you know how to format the null and alternative hypotheses to test the difference between two means. Now in objective number 3 we're going to cover the formal steps for performing a two-sample t-test for the difference between two means using independent samples with the standard deviations for the populations unknown and unequal. So as you've seen before, a t-test is used in the following situation. For two samples, we're testing the difference between two means called mu sub 1 and mu sub 2, and the 4 conditions that we're going to want to be able to check is that the sigma 1 and sigma 2 are unknown, our samples are random, the samples are independent, and remember this conditions about the population either to be stated as normal or the sample sizes are both at least 30. In this case, when we gather our data, remember it's quantitative, something like comparing test scores, we'll have a mean from the first sample and a mean from the second sample. And what we're going to do is we're going to subtract those two means, and that's the sample statistic of interest. Now to standardize that, we're going to calculate a t-score. And when we calculate a t-score, we get something known as a test statistic by taking the observed difference in the sample means minus the hypothesized difference for the two population parameters over what we call the standard error of that statistic. Now in my AP Stat class, we spend a lot more time talking about the math behind this thing, but for you guys, this denominator is just going to be an equation that you plug values in. So remember, when we use a t-distribution, we have degrees of freedom. So the degrees of freedom and that standard error calculation are dependent on whether the population variances sigma 1 squared and sigma 2 squared are equal. We are only going to cover the two-sample t-test for the variances unequal. Variances unequal. So when those variances are unequal, the standard deviation equation looks like this. My dog is trying to interrupt this recording. Okay, let's try this again. So in the scenario of the variances being unequal, the denominator of that test statistic is going to use this equation. It's going to take the square root of the variance from sample 1 divided by n1 and the standard deviation squared divided by n2 from the second sample. The degrees of freedom situation, if you remember in the t-test that we did when there were one sample, we just took the degrees of freedom equal to n minus 1. Well, now these sample sizes might not be the same. So we're going to go for whichever one is smaller and subtract 1. If you're using technology, some of the technology shortcuts that I'll be showing you, the degrees of freedom are calculated from a much more complicated formula that you're not responsible for. Okay, so the formal steps for doing a t-inference procedure. Just like the last chapters where we broke it down to 6, 7, or 8 steps, I've got 9 for you in this one. So first, you're going to verify a couple of things. That the two standard deviations are unknown. The samples are random and independent. Either the populations are normal or both of the sample sizes were at least 30. Number 2, we're going to write out the null and alternative hypotheses using symbols. Remember that it's important to identify which one is the claim. Number 3, we're going to identify the significance level for the test. Remember the letter for that was alpha. Number 4, we're going to have to make sure we summarize the summary stats for the samples. So there's going to be 3 things, x bar 1, s1, and n1, and then 3 things from sample 2, x bar 2, s2, and n2. And then we're going to calculate the test statistic, and we're going to use the t equals equation that was above. Okay, we're going to get the degrees of freedom if we're doing this by hand without our special calculator shortcuts. Whichever sample is smaller, subtract 1. And then we're going to use TCDF to get the tail area. Then we're going to make the same decision we would have in other chapters, which is reject H low if P is low. So the p-value's got to be less than or equal to alpha to reject HO, and then we're going to finish by interpreting the decision in context. So the next page, we're going to practice that. Okay. So here's the scenario. The results of a state math test for random samples of students taught by 2 different teachers at the same school are shown below. Can you conclude that there's a difference in the mean mathematics test scores for the students using the 2 teachers? Assume the populations are normal and the population variances are unequal. Okay, so it's not super specific, but it sounds like there's a claim of a difference between the 2 scores, and we're asked to see if that difference is significant. So in this hypothesis test, if we follow the 9 steps that are listed out on the previous page, follow along with me. So number 1 is for me to list out, as stated in that slide, that we have sigma 1 and sigma 2 unknown. We have random and independent samples. And we have both populations are normal. I also noticed when listening to the recording that the tapping of my Apple Pencil on the screen is potentially a little bit annoying. Sorry about that. If I write in cursive, my pen won't tap the screen as much. All right, step 2 is for us to state those hypotheses. So it sounds like there's a claim that 2 means are different. So I'm going to write that next to H sub A, that the mean for population 1 is different from the mean for population 2, and we'll make that our claim. And therefore the null is just that mu sub 1 equals mu sub 2. Step 3 is to specify the significance level of the test. So we're going to just write 0.10 from the question prompt. Step 4 is to list out our summary stats. So since we didn't have to fish those out of the paragraph ourselves, I'm just going to say see summary stats above. I don't see a need for us to list them again. Step 5 is for us to calculate that test statistic. So if you took the slide that was on the previous page, here's what it looks like. X bar 1 minus X bar 2. And then we have to subtract from that the mu sub 1 minus the mu sub 2. And then we have to divide by the square root of, divide by the square root of S1 squared over N1 plus S2 squared over N2. So the X bar 1 minus X bar 2 comes out of the chart of summary stats, 473 minus 459. Okay, now notice the null hypothesis is that mu 1 equals mu 2. So that means we're hypothesizing no difference between the means. So this is going to usually be 0. Okay, and then we're going to divide by the square root of S1 squared over N1, so that's 39.7 squared over the first sample size 8, plus 24.5 squared over the second sample size, which was 18. Okay, so like I said in the opener, this is a little bit more complicated with your calculator, but if you type it just like that into your calculator, you should be able to work out that this just comes out to 0.92 for the t-value. Okay, so step 6 is to get the p-value. So the p-value for the test is the tail area for a test statistic of 0.092, sorry, 0.92, doubled because we're doing a two-sided test. We also should write degrees of freedom down here, and the smaller sample size was 8, so we'll do 8 take away 1, or 7 degrees of freedom. So my p-value is going to be 2 TCDF 0.92, 10,000, 7 degrees of freedom. Okay, so pause for a second and calculate that. I'll be right back. Okay, so I got t equals 0.92 when I work that out. All right, next, number 6 is we just calculate degrees of freedom. Remember, we're going to go to the smaller sample size and take away 1. 8 was the smaller sample size. Take away 1, I'll have 7 degrees of freedom. So in step 7, when I go to get the p-value, drawing my t-distribution, putting in the test statistic of 0.92, getting the tail area, and because it's a two-sided test, as in last chapter, you'll have to remember to double that. So I'll calculate twice the probability of getting a test statistic of 0.92 or greater. So this is twice the TCDF command with 0.92 for the lower boundary, 10,000 for the upper, and 7 degrees of freedom. And for that, I got 0.3882. Okay, step 8, that p-value is not low, so I'm going to make a fail to reject HO decision since the 0.3882 is greater than 0.10. And then number 9 is now to write the same sentences from chapter 7. My first phrase is, there is enough evidence. Next phrase is, because the claim's HA, it's, whoops, I failed to reject HO, whoops. So there is not enough evidence. And the claim's HA, so to support the claim that, the mean math scores for the two teachers are different. Okay, so there ends your first model problem, showing you the 9 formal steps in a hypothesis test that likes to compare the two means of two independent samples.